All right, so welcome everybody. So this is going to be lesson 6.1, graphing systems of equations. I know I'm sitting in the bottom right-hand corner of the screen, so you can't really see about the assignments due, but just know that homework is going to be on ALEKS again, and so please make sure that after you work on this lesson today that you go on ALEKS and you actually do the pretty simple, hopefully, homework that's due for this. Please make sure in your notes that you write the essential question. If you don't have the notes on you, they are on Canvas, so please make sure you go to Canvas and print them out. Remember, we still have a couple more weeks left. We'll be printing things out, and then we'll be moving quickly into where you guys have to print out your own notes, just as an FYI. All right, 4 topics as well are doing ALEKS, and here is your bell work. What I would like you guys to do is please solve this first equation here, solving the inequality, and then work on the second one as well in pertaining to graphing the inequality or writing. Please ignore this question in the middle. Pause the video and get started, please. Alright, so hopefully you guys were able to do this bell work on your own. Remember, this is all about you and your honor system, ladies and gentlemen. I just want to make sure you guys understand how to do this stuff. So the simplest way to actually solve this one would be to multiply everything by the reciprocal. So it would be multiplying both sides by 5/2. And so you'd have W is less than or equal to, and then 6 times 5 is 30. Divide that by 2, and you'd have negative 15. And then write an inequality that represents this graph. Now I didn't have to go down too far because hopefully you guys could tell they have a point here, and then there is going to be a point, it looks like right about here. So let me go the opposite direction, make sure. Yep, okay. So remember we're going for similar to y equals mx plus b, right? But it's going to be y. We know there's an x. Our b is going to be plus 1. And then our slope is up 3/1, so our slope is 3. Now the question is what way is this inequality go? Is it go left, or is it going to go right? And so what I wanted you guys to do is to actually graph a point on the line. So I'm going to pick the infamous 0, 0 point. Okay. You plug in zeros here, and then that's going to multiply out to be 1. And then it's going to be, whoops, not y. Then it would be 0, an ugly 0, and 1. So out of these, 0, 0 falls in here, and it needs to be a false statement. And so which one of these is a false statement? Well, actually, it's this one. So that means this is your graph. If I wanted to test a point that's legitimately on the line, I could go 0, 2 as a point. Okay. And if you do that, you'd have 2 here. You plug in a 0 there. Is 2 greater than 1? Yes, it is. So we know we're on the right track and that this is the actual equation. So now what we're going to be doing today is we're going to be doing a lot of graphing. This is going to be another Desmos lesson. It's kind of going to be easy for you guys. We are going to interpret the graphs first, okay? Because we're talking about solving a system of linear equations where we're going to have 2 equations and they are going to either cross or they will be what's called dependent or independent. So on your notes, I know there's a lot of vocabulary on there, and I'm looking at it on the book right now. It talks about if it has at least one solution, it's called consistent. Okay, so that, ladies and gentlemen, is actually what we're looking for. Okay, where it's going to be consistent and independent, where you have exactly one solution. So please make sure you guys circle and annotate your notes like you have been doing in the English class. I want to make sure you guys continue to do it with me. And then also, if you guys look at your notes, here's the main contemporary of what we're talking about, where terminology of being consistent and independent are 2 graphs, okay, 2 equations that when you graph them, they create one solution that would be right here. Okay, infinite solutions would be consistent because there is a solution, but it's dependent, which means there's actually 2 lines graphed on top of each other. So it's kind of the infinite solution thing. And then inconsistent would be, of course, 2 parallel lines. So let's begin. All right, use this graph and just tell me whether this is consistent or inconsistent, and if it's independent or dependent. So if you guys look at your chart that's right above it, if I have two parallel lines, then of course this is going to be inconsistent. Okay, is there a solution to this? The answer, of course, is no, there isn't. So please make sure you guys are fully aware of that. What happens if I graph two equations like this and we have one solution set? Is this consistent or inconsistent? And then is it independent or dependent? Well, if you guys look at your table, you're going to have consistent, and I spelled that wrong. Let me start over with that one. That's horrible. It's going to be consistent, and it's going to be independent. So I just want to make sure you guys understand the terminology by looking at this picture. Okay, it's a graph. So if I ask you on a test, can you tell me if it's inconsistent or consistent, and then is it independent or dependent? You can tell me on the test. All right, so what I want you guys to do now is please go into Desmos and graph these. Now, if you guys want to write these equations, you can, okay, because you're given the y-intercepts here and your slopes, so some of you might be able to do that, but for everybody else, go ahead and check out Desmos. All right, so on Desmos, ladies and gentlemen, our first two equations up, that is going to be consistent and independent. And then our second guided practice is negative x, and that one as well is going to be, make sure I did that one right, x minus 5, negative 2x minus 5. That one as well, ladies and gentlemen, is going to be, hold on, make sure I didn't miss anything. Oh, okay, I didn't, good. That one as well is going to be consistent and independent. So it's interesting that we put both on there. Okay, so now what we're going to do is we're going to just talk about simple graphing a system of solutions and then determine whether there is no solution, one, or infinite. All right, pretty basic. And if it has a solution, then name it. So what we're going to do is on Desmos, I want you guys just to graph these straight up. Okay, so if you graph it straight up, let me delete these two equations. My first equation is y equals. Now remember, in Desmos, you don't necessarily have to put y equals, which is why it's not here. It's a given if you do not put it. And then the other question is that. So ladies and gentlemen, did you see the color change? Watch it again. Ooh, color change. So that actually means what? It's going to be two lines on top of each other, and it has an infinite many solutions. All right, graph this system of equations. Let's do the next one. Let's see what these have. So let me delete these two. We'll move on to the next two. There's one. There's two. Ladies and gentlemen, what do you think that's going to have there? Is there ever going to be a solution for that? The answer is what? No. No solution. Okay. Two parallel lines. All right. So I just need to make sure you guys understand this concept about what happens when you have those two. All right. Your turn. In Desmos, graph these two out real quick, and then give me your answers. All right, hopefully you guys pause the video and you're checking it yourself. All right, simple enough. Graph the next two. And this one actually has a solution. Now, the cool thing about Desmos is that I do want you guys to put this on your notes when you graph it. But Desmos actually will bring the point up for you, so you can click on the intersection. So does this have a solution? Yes. This is consistent and independent. Okay, that's one thing I want to make sure you guys know. And then consistent and independent. All right, and then when you graph it out, because I do want you to, I'm not going to graph it here because it'll take too long. You guys need to graph it out. But what I want to make sure you guys understand is that, is there a solution? Yes, there is. The solution is 3, 1. And what that actually means is that if I plug it into this equation, so if my point is 3, 1, my x is 3, my y is 1, well, 3 minus 1 is what? It's 2. So 2 equals 2. And if I put a 3, 1 here, I get 3 times. If I put oh, sorry, that's backwards. See, they tried to get me on that one. If I put a 3 here and a 1 here, this is actually going to be what? 3 plus 6, which equals 9. So it's a solution for both of the equations. So that's what our goal is to try to find the solution for both equations. Okay, hopefully you guys understand that concept. That's all we're going for. Is there a solution? And then so for 2b, if you guys figured out 2b, mark these two up, and watch the color change again. And of course, that is what? That is infinite solutions. Oops, there's my video. Infinite solutions. Okay, so knowing that on this one here, it is infinite. All right, and then also if I ask, it would be consistent and dependent. Consistent and dependent. Okay, so same thing. All right, sorry for my ugly chicken scratch. All right, so next, now we're going to deal with a real world problem. Because sometimes, and we'll get more into business finance stuff as we move along, because I know that was the guided practice, or the essential question. For this, Nareesh rode her bike, or his bike, 20 miles last week, and plans to ride 35 miles per week. Diego rode 50 miles last week, and plans to ride 25. Predict the week in which Nareesh and Diego will have ridden the same number of miles. So we need to form an equation for that. And the equation for this is right here. So I didn't want to take the time to do it. I let the book do it for me. All right, so Nareesh's equation is started off, they are going 35 miles a week. They started with 20. And Diego started with 50, and they are going 25 per week. So what you would do is you would just graph this real quick. Okay, when you throw this graph up, then you need to zoom out. Let me zoom out quite a bit. And then what you can do is, see, we're out kind of far, and I can't see where it intersects. But if you just tag the line, you see this little dot that appeared. There, ladies and gentlemen, is where you can... do I have to zoom in any farther? No. It actually would give you the intersection of Desmos, which is really cool. Okay, so what does this point mean? Well, this means that after... if y is 125 and x is 3... it's going to be after 3 weeks, they will have ridden the same miles, and the actual mile total will be what? 125 miles. Okay, so if x equals 3, so x equals 3, after 3 weeks, they will have both ridden on their bikes 125 miles. Hopefully you guys can understand that, and that's the juxtapose of what we need to do for this lesson. Okay, last but certainly not least, here's the video games one. Try to see if you can piece the equation together, and then we'll go from there. So pause the video, please, and try yourself. All right, so with Joe, let's do Joe. Joe started. Now, I could write this appropriately or inappropriately. What I mean by that is putting the X in the right spot, but I'm just going to write like I see it. So Joe has $14, and then he's going to save $10 a week. So that would be 10x. Josh has $26, but he's going to save $7 a week. And how many weeks will they have the same amount of money? So on this one, you just do the same thing, okay? You figure out your equations, and you would graph them. Let me turn them both on. Now you can see I'm zoomed out pretty far, and I can't tell, but if I click on one of the lines, you see the dots appear right here. Now this is the intersection, so of course you wouldn't click on those. But if you look on the dot right there, so my x is 4 and my y is 45. Okay, so if my y is, wait, not 45, right? Oops, sorry. 54. My y is 54, and then my x is 4. So the answer then is what? In how many weeks will they have the same amount? It would be after 4 weeks. Okay, because my point was 454. All right, so that's it. Okay, it's graphing two equations where they intersect. That is the answer. So that's the main focus that we're going to be having on as we go forward. We are going to be some more complicated algebra, starting with lesson 2, but I wanted you guys to understand how the system of equations works. If you're within my classroom, you'll have an exit ticket coming up next. But for everybody else, if you missed this day today, don't worry about the exit ticket, and instead get an ALEKS and work on your homework. Ladies and gentlemen, hope you enjoyed this lesson, and I will see you soon in class.